The Mikoyan-Gurevich MiG-105, part of a program known as the Spiral, was a manned test vehicle to explore low-speed handling and landing. It was a visible result of a Soviet project to create an orbital spaceplane. This was originally conceived in response to the American Boeing X-20 Dyna-Soar military space project and may have been influenced by contemporary manned lifting body research being conducted by NASA's Flight Research Center in California. The MiG-105 was nicknamed Lapot Russian, or bast for the shape of its nose. Development. The program was also known as EPOS. Work on this project finally began in 1965, 2 years after Dinosaur's cancellation. The project was halted in 1969, to be briefly resurrected in 1974 in response to the U.S. Space Shuttle program. The test vehicle made its first subsonic free flight test in 1976, taking off under its own power from an old airstrip near Moscow. It was flown by pilot Aviad-G Fastovets to the Zhukovsky Flight Test Center, a distance of 19 miles. Flight tests, totaling 8 in all, continued sporadically until 1978. The actual spaceplane project was cancelled when the decision was made to instead proceed with the Buran project. The MiG test vehicle itself still exists and is currently on display at the Monino Air Force Museum in Russia. Gleb Lozino-Lozinsky was the leader of the Spiral development program. Differences between Dinosaur and Spiral. Although having basically the same mission, Dinosaur and Spiral were radically different vehicles. For example, while the X-20 Dyna-Soar was designed for launch atop a conventional expendable rocket such as the Titan IIC Saturn I, Soviet engineers opted for a mid-air launch scheme for Spiral, known as 50/50. The idea was that the spaceplane and a liquid fuel booster stage would be launched at high altitude from the back of a large, air-breathing mothership traveling at hypersonic speeds. The mothership was to have been built by the Tupolev Design Bureau and utilize many of the same technologies developed for the Tu-144 supersonic transport and the Sukhoi T-4 Mach 3 bomber. It was never built. Dinosaur was designed as a lifting body, while Spiral was a conventional delta that featured an innovative variable dihedral wing. During launch and re-entry, these were folded upward at 60 degrees. After dropping to subsonic speeds post-re-entry, the pilot lowered the wings into the horizontal position, giving the spaceplane better re-entry and flight characteristics. Spiral was built to allow for a powered landing and go-around maneuver in case of a missed landing approach. An air intake for a single Kolosov turbojet was mounted beneath the central vertical stabilizer. This was protected during launch and re-entry by a clamshell door which opened at subsonic speeds. By comparison, Dinosaur was designed primarily for a once-off, unpowered dead-stick landing. High-temperature superalloy metals such as niobium, molybdenum, tungsten and Rna-41 were to have been used in the heat shield structure of the X-20. Spiral was to have been protected by what Soviet engineers termed scale plate armor, niobium alloy 5 and molybdenum disilicide plated steel plates mounted on articulated ceramic bearings to allow for thermal expansion during re-entry. Several Ballcraft were flown to test this concept. In the event of a booster explosion or in-flight emergency, a crew compartment of Spiral was designed to separate from the rest of the vehicle and parachute to Earth like a conventional ballistic capsule. This could be done at any point in the flight. Such an escape crew capsule was also considered for Dinosaur, but American engineers eventually opted for a solid fuel escape rocket that would kick the spaceplane away from an exploding booster, hopefully saving both pilot and spacecraft. Much like the Space Shuttle, Dinosaur was designed with a small payload bay behind the pressurized crew module. This could be used for lofting small satellites, carrying surveillance equipment, weapons, or even an extra crew member in a pop-in cockpit. Spiral, on the other hand, was intended to carry only its pilot. Both Dinosaur and Spiral were designed to land on skids. The landing skids on Dinosaur were designed to deploy from insulated doors on the underside of the vehicle, like a conventional aircraft. Soviet engineers designed the landing skids on Spiral to deploy from a set of doors on the sides of the fuselage just above and ahead of the wings. Pilots. A cosmonaut training group for pilots assigned to fly this vehicle was formed in the early 1960s. It went through many changes and was eventually dissolved entirely. Known members included German Titov, the second man to orbit the Earth, the Vasily Lazarev cosmonaut who would later fly the first Soyuz 7KT mission, Aviad G. Fastovitz, who piloted the vehicle during the majority of its atmospheric tests. Another spacecraft to use the Spiral design was the Bohr series, unmanned subscale re-entry test vehicles. American Analog's X-23 prime and asset. Several of these craft have been preserved in aerospace museums around the world. Operators: Soviet Union, Soviet Air Force. Specifications: data from Soviet X-planes. Yefim Gordon, Bill Gunston. General characteristics: crew 1. Length 10.6 meters. Wingspan 6.7 meters. Height m. Wing area 24 square meters. Empty weight 3,500 kilograms. Loaded weight 4,220 kilograms. Useful load kilogram. Max takeoff weight kilogram. 500 kilograms fuel. Performance never exceeds speed kilometer per hour. Maximum speed 800 kilometers per hour. Cruise speed kilometer per hour. Stall speed kilometer per hour. Range km. Service ceiling m. Rate of climb meter per second. Wing loading 175 kilograms per square meter. Landing speed 250 to 270 kilometers per hour.